Look, here is the Earth and this is the Sun. This part here is witnessing sunrise, while this one here is witnessing sunset. And this one here is witnessing midday or noon. And this one here is witnessing night. Now we know the world's time is coordinated using the 0-degree longitude which passes through Greenwich, called the prime meridian. For now, let's call a place located on this longitude as A. So at this position, let us assume it is 11:59 a.m. on Monday, that is 8th of August. So people at this point are waiting for their lunchtime to start. Now, exactly opposite to this point is this place. Let's call it point B. What would this longitude be? Any guesses? Yes, exactly opposite to the 0-degree longitude will be the 180-degree longitude. The time here would be exactly 12 hours ahead of point A, which is 11:59 p.m. But still, Monday, 8th of August. This means that most people in this part of the world would have already ended their day and would most probably be asleep. Let's go 2 minutes forward in the future. So at point A, it is 12:01 p.m. and it is still Monday, 8th of August. However, at point B, the time is now 12:01 a.m. and it's Tuesday. The date here has changed to 9th August. Let's assume one more point, point C. Point C is little bit behind point B. Let's say by 5 minutes. So the time at point C at this moment will be 11:56 p.m. on 8th August, Monday. It means if a person living at point B travels from point B to C, he would be back to Monday from Tuesday. And on the other hand, if someone living at point C travels to point B, the day would have changed to Tuesday. All this is happening at the 180 degrees longitude that has a special name called the International Date Line. The International Date Line passes through the mid-Pacific region. Thus, we can say that the International Date Line functions as a line of demarcation, separating two consecutive calendar dates. Just see how this happens over a period of 24 hours. Let's assume it's 12 a.m. on Tuesday, 9th August at the International Date Line. As we move forward, it's Tuesday for this part, and for the rest of the world, it's still Monday, 8th of August. As we move forward, Tuesday gets bigger and bigger, and Monday gets shorter and shorter. Finally, let's stop here when it's 11:59 p.m. on August 9th at the International Date Line. A very large part of the Earth is on the same date. And a minute later, there is a new day at the IDL, and the cycle continues thereby. Thus, we can see how on the east and west of the IDL, there are two dates, and if someone crosses the IDL, they would witness a change in the date. So we can generalize this observation. Okay, this is our Western Hemisphere, and this one is the Eastern Hemisphere. The Western Hemisphere is on the east of the IDL, and the Eastern Hemisphere is on the west of the IDL. If you move from the west of the IDL to the east of the IDL, you gain a day. This means that if your current date is 9th August on moving towards the east and crossing the IDL, your date will now become 8th of August. So you have gained one day. On the other hand, the opposite would happen when you cross the ideal by moving from the east of the ideal to the west of the ideal. You would lose a day. In the 21st century, the international date line is used to coordinate international airlines, transportation services, and other trade activities. The ideal, in fact, allows us to keep track of the date and time accurately for global transportation, especially with trans-Pacific air travel. The international date line is not a straight line like other longitudes. It's quite irregular, like a zigzag line. Why? Well, see this. The line starts straight, but it changes its course so that the easternmost tip of Russia near Kamchatka doesn't get on the other side of the IDL. Then it passes straight through in between Russia and Alaska. After that, the line again changes its course and continues its course to accommodate these islands so that all of them witness the same date. That's because all of these islands are actually a part of Alaska. These deviations of the international date line from the anti-meridian ensures that no country should fall in a zone where two different dates are observed in two different parts of the same country. To accommodate such irregularities, the ideal is not straight but rather a zigzag line. We will now learn about the great circles and their importance. We know that the Earth is spherical in shape. Therefore, on the Earth's surface, when we travel across any 2 points, we will be traveling through a curved path. There are many paths one can follow. All these paths will subtend circles of various sizes. You can imagine these circles to be solid disks. The circle whose solid disk passes through the center of the Earth would have the largest diameter. This circle is what we call a great circle. The circle whose solid disk does not pass through the center of the Earth is what we call a small circle. Now, coming to the importance of why we study these great circles. The answer is to calculate the shortest distance between 2 points on Earth. Let's take an example. This is Moscow, and this here is Tokyo. If I ask you to draw a path that is the shortest distance between the two places, how will you draw it? Something like this, isn't it? It means if I ask you in which direction you would head to reach Tokyo, your answer would be in the southeast direction, right? Well, that's not true. The line that you drew on the map was actually this line that passes through the inside of the Earth. And we know we can't take that route, right? So what's the solution? Well, all we have to do is to figure out a great circle which encompasses both Moscow and Tokyo. And here it is. Let's see how it looks like on a flat surface or on a flat map. See, it looks like a curved line on the flat map. And if I were to ask you the same question again, which direction will you head to reach Tokyo? What would your answer be this time? Obviously, it will be northeast, right? So next time, if you see the route between 2 points is joined in a curved fashion instead of a straight line, you will know that the curves show the shortest distance between 2 points following a great circle. That is the reason why the ships sail following the great circle in order to save fuel and time. Now, can you tell me which longitudes and latitudes are great circles? Well, all longitudes are part of the great circles. Then what about the latitudes? Well, the equator is the only latitude that is a great circle. Apart from them, all other latitudes are small circles. I think one question you all must be eager to ask. Why is the path along the great circle the shortest? Well, we know that the great circle is the largest possible circle between any 2 points on Earth. Now consider point A and B. These 2 points can be connected through curved paths of various diameters. As you can see, here's a circular path that we can travel to reach from point A to point B. Now, another circular path can be this. Well, can you see that? When it is a larger circle, the path which is connected becomes shorter. Therefore, when we take the path of the great circle, which has the largest diameter, the path that is connected will become the shortest.